Hello, my name is Tan Lee. I'm a member of Group 2, and this is our PowerPoint presentation for image reconstruction with TensorFlow. Throughout this project, we are guided by our group sponsor, Professor Z. Gang Lee. Group members consist of our team lead, John Portzabowski, Tan Lee, Taylor Thomas, and Daniel Head. For this project, our main objective was to incorporate the use of AI and deep learning to compensate for the downgrade in quality in video streaming due to packet loss. This is an undesired problem that a lot of people face in all forms of media. The thing we needed to do was we needed to address and understand what the problem was. The problem here is packet loss. So what is packet loss? Packet loss usually occurs in the transmission of packets to their desired destinations. When all of the packets of data are not fully pieced back together, noticeable effects can take place in all forms of data. The data may reproduce errors, video messaging may become blurry and stutter, and in the case of this project, packet loss can mutilate images by removing pieces of the image itself entirely. So for example, let's try to transmit this photo of this man, have packet loss occur, and this is what we can end up with. Bits and pieces of the picture being removed, along with tears, which is a downgrade in quality. So, how did we go about fixing packet loss? We understood the scope of the project and what it was asking. We were to take a video of our own and create a program that will take a video and export the pixel values of an entire video to a text file that contains a 16 by 16 block that is missing, which would essentially represent the data loss. Through our research and analysis of the text files we've created, we found that the data loss is represented by zeros, essentially the color black. Once we've acquired this text file, we were to set up a neural network with the use of TensorFlow. This neural network that uses AI and deep learning would essentially process and learn from the data that we feed into it, in the hopes that we'll be able to produce an image with repairs to the missing black square we created, basically filling in the black square as if it was never there. When it came to our group and our experience with Python and OpenCV, it was safe to say that none of us had ever worked with either of the two. Python, being a relatively simple programming language coupled with OpenCV, a simple language library for image processing, it would prove to be a very difficult task for the inexperienced like ourselves. Knowing these two topics would be a very crucial aspect of the project, and we knew that we had to learn the basics at minimum in order to proceed to the next step. John and I exalted many resources online for as much information as possible in order to create a program that would extract the pixel values of an entire video to export to a text file. This was our first big hurdle in the project, and we feel that as a group we performed as well as we could. In this quick demo, I will run over our script that we created that will take in a video and output it to a text file with every single pixel value along with packet loss that are represented by zeros, which is essentially the square. I would like to note that we imported CV2, which is OpenCV. We have also imported NumPy, which is a mathematical library that will help us in our compilation. Over on this side, we have our folder, which is where all of our data is set. In this folder is our input video. This folder represents an AVI output. Essentially, we'll be able to output a video that represents the packet loss, along with the folder that will contain the text data that we create. Over here, we have our X and Y values. We can set this parameter to whatever we want. Whatever we set it to is the placement of where the packet loss will be in that square, the size of the square, along with the frame jump. Frame jump is how many frames the program will jump to and apply the packet loss. For the sake of this video, we will set it to 10 like we had it. We'll save it. Down here we have our output folders. We have our for loop that will run until the very end of the video and then we'll break. We'll now execute. As you can see, we're running through intervals of 10. Once our program is complete, we'll be able to evaluate the text file that is created. I'm sorry about the wait. It takes a while for the text file to open up. Here, I've searched within the text file itself for the 0 values that represent the packet loss. To the next folder, we also output an AVI video that also shows where packet loss is located in the video. Taking a closer look at our data, here's some screenshots. Now that we have our training data that we created with both Python. For the second portion of our project, we had to utilize TensorFlow, an AI and deep learning platform. TensorFlow is a machine learning framework created by Google that is utilized to build and train deep learning modules. The library within TensorFlow allowed us to perform numerical computations, which is actually very similar to the previous program we used to create the training data. A big difference between the two is that TensorFlow computes with data flow graphs. Within these graphs consist of nodes that are represented by mathematical operations that process and memorize data that it is learning from. TensorFlow is a very powerful machine learning platform. It has many different applications such as search engines, object detection, and in the case of our project, image reconstruction. Here we can see an example of TensorFlow being able to distinguish what is a cat and what is a dog. This is done by training the neural network with thousands of images of the two animals. Another great example is object detection of a variety of different objects. You can see the neural network is able to distinguish between a person and a laptop. Our goal with TensorFlow was to set up the training network with a single image in order to feed it to the network with a separate image that contains a black square in hopes that it would output an image with a repaired image and no packet loss. We had a lot of difficulty in transitioning to phase 2. Setting up TensorFlow was a process within itself. We utilized Anaconda for kernel creation and launcher for our TensorFlow environment. Once the environment is established, all coding and processing was done within Jupyter. Anaconda is a free open source that utilizes the Python programming language for many forms of scientific computing, such as machine learning. Two great features that Anaconda provided for us was its library of packages that can be imported along with its amazing GUI. Anaconda Navigator. In order for our neural network to perform correctly, we had to import the correct dependencies in the kernel creation. Anaconda Navigator's interface allowed us to simply select the packages such as TensorFlow and NumPy and install them on the spot for our environment. In this screenshot over here in the home, we can see that we can simply launch the Jupyter Notebook. There was never a need to open up a command prompt, type in a command, and execute. Everything was launched from a simple click of the button. In the Environments tab, we can see a library of dependencies we could have chosen from. There were honestly hundreds. All we had to do was go through, select which ones that we needed, and click Install. All of our data processing was done within the Jupyter Notebook environment. It's an open source web application where not only were we able to implement our code, but we were also able to visualize data in real time along with the output. The interface proved to be a very clean and simplistic program. Taking a look at this screenshot, in the upper right hand corner, we can see the name of the kernel that we are currently using. This was a good reminder for us that we were using the correct kernel that we created in Anaconda Navigator. Looking at the toolbar, there's not a lot going on. We found this as a great benefit. Tools such as adding and removing cells, moving the cells around, running and stopping the code were the only things that we really needed. Executing code within the Jupyter Notebook was performed in cells. Cells process in sequential order. So if cell 3 does not process, cell 4 does not process. This was a great tool for us to use in order to debug and see where issues were within the code. And this is our program that we used within TensorFlow that will Here we have several images from our training program that show a timeline of improvement. We can see that there is a tremendous image improvement within the first few hundred iterations. As the number of iterations increase, the loss value begins to decrease and an image of a cliffside begins to form. We can see that the fourth image, there is a visual inconsistency in the shape of a square, which is where our packet loss originally was. As time goes on, the image became more and more clear, with it becoming more difficult to differentiate an image from the previous one. The image at the end is the product of after 1700 iterations. We are confident that if our program ran much longer, it would output an image that would replicate the original image perfectly. So let's recap. We were presented with a project that would utilize AI and deep learning to repair packet loss in video streaming. From the beginning, we knew that we had to learn Python. None of our group members had ever had experience with the programming language. We spent many hours watching videos and reading through many resources. Knowing that this was a vital aspect of the project, we pushed forward. We were able to create a script using the Python programming language and the import of OpenCV to process an image and output the pixel values with the missing packets to a text file. From there, we knew that we were moving in the right direction. Our group had never worked with Python, let alone working with AI and deep learning frameworks. Knowing that we had to utilize TensorFlow to process our data, we read through numerous documentations and videos to set up and use the platform. Once we started to gain momentum, we were faced with a very large hurdle in learning how to process the text file through TensorFlow to output a video. We knew we wanted to create a deliverable that would reflect the goals of this project, which was to train an AI network to repair and output an image. Once we got our approval from our sponsor, we hit the ground running. We found that through our hard work, we were able to create a program through TensorFlow that would take a single image, create packet loss, and output an image through deep learning. Looking back at this project, we would like to say that this was a very difficult project, but also a very fulfilling one at that. We were faced with a task that seemed impossible relative to our skills. We were working with AI and languages that we have never even touched before. Learning Python in and of itself was a challenge, but coupled with TensorFlow, it seemed impossible. We knew that we had to come together as a team and approach this in a manner that would allow us to perform a semester-long project in a shorter amount of time. A lot of the project management skills were put to the test that we learned in previous courses. Also, a lot of teamwork and communication came into play when problems arise. Although AI and deep learning is still a difficult topic for us to really grasp, we have a greater appreciation for it and have a different lens when we see all of the technology around us today. Lastly, we would like to thank Professor Lee for his guidance throughout this project.